Okay, this is part two of calculating parenteral dosing, and we are going to talk about calculating ratio strength. So I have covered this already, but I'm going to touch on it because this seems to be one of the more challenging things for pharmacy technician students to understand. So medications can be expressed as ratio strengths, which can be in a percentage here or a ratio like this. Now remember, and I'm going to make this very clear, remember, when you're converting ratio strengths into fractions, you must remember if it is a weight over weight, weight over volume, or volume over volume. So, and why I say that is you must be very well aware of the units that go along with each one. Okay? So, for example, how many grams of active ingredient are in 50 milliliters of a 1 to 200 solution? Well, I'm going to make this ratio strength into a fraction, and I got to make sure I put units on it. And when I do that, it should be 1 gram over 200 milliliters. Okay? Now, a lot of times we calculate in milligrams, but when we put it into a fraction from a ratio strength, it's in grams. So pay attention to conversions. Make sure you are aware if you are going to need to do any converting, okay? For this one, we don't have to because it's asking how many grams. So we're going to set its X is how many grams. That's what our X is. So we're going to set it over 500, and then your solution, I'm just doing it by ratio proportion here, but you guys can do it by dimensional analysis if you'd prefer, and we're going to cross multiply and divide. So 1 times 500 is 500 divided by 200, and our answer is 2.5 milliliters. So I think the biggest problem people have with this is putting the right units on the ratio strength. So let's go ahead and look at another problem. Okay, so here, how many grams of active ingredient are in 5 milliliters of a 1 to 3,000 solution? So we're going to put this into a fraction first. Let's put this into a fraction. And we are going to go ahead and we do know that it is a weight over volume because we have volume here and weight here. I also know it's a weight over volume because it's asking me how many grams of active ingredients. So that is my top number. So it'd be X grams over active drug in 500 milliliters. So it's giving you a total volume of 500 milliliters down on the bottom. So now we're going to set that equal to our ratio here, which is 1 gram over 3,000 milliliters. Okay, so now we can do our cross multiplying and dividing. So 500 times 1 is 500, and then we're going to divide that by 3,000. So 500 divided by 3,000 ends up, let's try that again. 500 divided by 3,000 ends up being 0.17 grams. And that's our answer right there. Okay, so we can do one more, and I'm going to do this one. I wanted to show this one because it tells us how many milliliters are we calculating. Okay, I'm going to put this in my, and it asks for how many milliliters, and it is giving us milligrams. So we might have to do some conversion here because we have a ratio strength of a 1 to 500. So let's start by looking and making sure that these are set equal to each other. And since one gram equals 1,000 milligrams on our conversion sheet, we're going to go ahead and start with that. So we're going to do 1,000 milligrams over 500 milliliters. because that's the same as 1 gram over 500 milliliters. We're going to do 1,000 milligrams. We're going to set that equal to 20 milligrams because remember our units have to match and we're matching now and we are calculating X milliliters. So now we can go ahead and cross multiply and divide. 500 times 20 is 10,000 divided by 1,000. Our answer is 10 milliliters. And that's our correct answer there. And that's how you calculate that. Okay, moving on to the next problem. Powdered vial dosing. Powdered vial constitution dosing isn't very common. I don't know if you guys will have to do this, but you never know what they're going to cover on the PTCB. So when you look at a powdered vial, we receive medication in lyophilized medication. And the reason they do that, instead of receiving everything already reconstituted, it gives it a longer shelf life. So we receive it in this powdered form, and then we add a diluent to it to reconstitute it right before we're going to give it to the patient. So the shelf life is longer. Otherwise, they would probably go bad in a few, in, like an hour or two. So I don't know if you guys remember the COVID vaccine. The minute we would receive it in a in a dried solution, and then we'd reconstitute it. Once we tapped that vial, we had to use it in a certain period of time or we had to throw it out. So that's why we do it. It's just for shelf life. But you got to understand that that powder takes up a space. There's a volume to that powder. So sometimes you have to figure out what a powdered volume is, the amount of space that dried powder takes up. And that's what a powdered volume is. The diluent volume is the amount of diluent that you add. And usually you find out, well, how much diluent do I add to reconstitute a powdered volume? Well, it'll tell you on the vial. If you look on the vial, it'll say add 9.3 milliliters of sterile saline or sterile water or whatever they want you to use as your diluent. And then your final volume is your powdered volume and your diluent together. So there's a formula here that you can memorize, or you could put, final volume equals powder volume plus diluent. I mean, it just however you want to write it. Usually I calculate this algebraically. Like I put in all my answers and then whatever, I just solve for X. That way I only have to memorize one formula. But that's up to you. If you want to memorize all the formulas, you can set, you can also put final volume, like you could type FV equals PV plus DV. That's another formula as well. So that's up to you, whatever you want to memorize. Okay. So our first question is, you are to reconstitute 1 gram of dried powder. Okay. We got a violin. It's it's a dried powder, and there's 1 gram in there. 1 gram of dried powder. So when we reconstitute it, it's going to be 1 gram. Now, the label states that you can add 9.3 milliliters of diluent to make the desired concentration. And once we dilute it, we're going to have 100 milligrams per 1 milliliter. Okay, so what is your powdered volume? So we're trying to solve for PV. So the first thing we need to do is, if you look here, we are in milligrams and we're in grams. So we're in grams and milligrams. So we want to convert. So we must convert to match the units. So 1 gram equals 1,000 milligrams. So we're just going to change that to 1,000 milligrams. That'll be easier. Okay. Now we know that the diluent volume, but we do not know the final volume. Okay. But this, with the information we have, we can determine the final volume, and we can do that through ratio proportion. So we know that there's 1,000 milligrams, but we don't know how many milliliters that is. That's our total volume. But if there's 1,000 or 100 milligrams per 1 milliliter, 1,000 milligrams is going to be how many milliliters? So if we figure that out, our final volume is right here, which is 10 milliliters. So now we know our final volume is 10 milliliters. So now you just plug them in. The final volume is 10, and the diluent volume is right here, which is 9.3. 10 minus 9.3, our powdered volume is 0.7. And that's how you figure that out. Okay? So let's look at another one. And this one's a little bit different because it's asking something different. So we have 6-gram vial, must have 10 milliliters of diluent added to it. So we know what our diluent is. It has a powder volume of 2. So we know our diluent volume is 10 and our powdered volume is 2. Okay, so you can do one of two things. You can memorize a formula because how many milligrams are in each milliliter of the solution. So it wants us to figure out what the final concentration is. It wants us to figure out this. Okay, so we do have the final volume, which is 10, and we have the powder volume, which is 2. Here's our formula, or we don't know our final volume, so we could do final volume equals powdered volume plus diluent volume. We could do that, or we could just put it in here and solve for x, which that's what I did. I put 2 milliliters equals x plus minus 10. And so to solve for x, we got to get x by itself. So we add 10 on this side and add 10 on this side, and you get 12. Or you can put it in here and put 10 plus 2 equals 12. So that's our final volume. So we know that. So if we have a final volume, we're saying there's 6 grams in 12 milligrams. So how much is in how many in each milliliter? So you'd ask for each milliliter. So now we got to figure out how many grams are in each milliliter. Well, each milliliter, there's 0.5 grams per milliliter. Because if you set this up as a ratio proportion, you're going to do 6 grams over 12, set that equal to x grams over 1, and you do your math, you're going to get 0.5 grams. So I could write that out. 6 over 12 equal to x over 1. Your cross multiply and divide. 1 times 6 is 6. 6 divided by 12 is 0.5. Now, that's great. We know it's 0.5, but what's it asking us? How many milligrams per milliliter? So now it's asking us how many milligrams per milliliter. So we must convert this 0.5 grams into milligrams. So you can do that one of two ways. You can either move the decimal point or you can set it up as dimensional analysis. I'm going to show you how. 1.5. So we're going from grams to milligrams. So we're going smaller. Remember, smaller's to the right. So we're going to move our decimal point 3 spots to the right. 1, 2, 3. It'd go right there. That would be our point. I'm not sure what I just did there, but we're going to add a 0 here and a 0 here, which would make that 500. Okay? And then, or you can set it up as dimensional analysis, which would be 0.5 grams times 1 gram over 1,000 milligrams, and then cross those off, and 0.5 times 1,000 is 500. So those are the two ways you can do it. Anyway, so that's it. I would go ahead and review those. We're going to do some practice problems on your review quiz, and hopefully that'll help you understand it a little bit better. Last that I want to talk about is variant units. So variant units, usually you notice we've been working with milligrams, grams, milliliters. That's usually what we calculate most of our medication doses in. However, there are some medications that have different units. We don't do math any different. The math stays the same. The units are different. And I just want to point that out to you so you don't get confused. So sometimes we have milliequivalents, which is used to measure electrolytes, such as potassium is a common one we use. Usually they give you the milliequivalents. You usually don't have to figure it out. If you needed to figure it out, you'd have to know the atomic weight of it and the molarity or the millimoles and all that. And we are not going to require you to know that. The other variant is units. And units is an actual measurement. So we refer to all of our labels as units, but also the word unit is a measurement for drugs like insulin, heparin, antibiotics like penicillin, any biological substances. We measure those in units. So just the problem can be solved just like all other dosing problems using ratio, proportion, and dimensional analysis. However, the units are just going to look a little different. And the key is to making sure that your units match each other. And as long as you can do that, you're good. Okay? So don't let that confuse you. So here I'm going to do a quick example of a problem here on milliequivalents for potassium chloride. You were instructed to add 16 milliequivalents of potassium chloride to a patient's IV bag. Using a single dose vial label below, calculate how many milliliters to prepare. So this is our dose in the pharmacy, and we have 20 milliequivalents. That's hard to write. Over 10 milliliters. And we're going to set that equal to, what is our problem asking? It says that we want 16 milliequivalents. Oh, it didn't like that. Let me go back. So I'm not going to write milliequivalents because it picks up too much. It gets too confused. So I'll do 20, and this is going to be ME. I'll just put ME over 1 milliliter. And we're going to set that equal to 16 milliequivalent. Okay, and that is over X milliliters. Okay, and that's it. You're going to still do your cross multiplying and dividing. So you're going to take 16 times 1, which is 16, divided by 20, and your answer is going to be 0.8 milliliters. That's what your answer is going to be. So really, nothing really changes. It's the same. Okay, let's take a look at the next one. If we're working with units. So this is heparin. Heparin's a medication used for a blood thinner if somebody comes in with a stroke. So we want to thin out their blood because they're clotting too fast. And our patient is to receive a bolus dose of heparin. If the dose is 75 units and you have a vial, here's what we have on file, 10,000 units per milliliter. How many milliliters would you prepare? So we have 7,500 units, and we are putting that over X milliliters because we don't know. And we're going to set that equal to 10,000 units. And we're going to divide that by 1 milliliter. So 1 milliliter times, and then you're going to divide by your ball. So 7,500 divided by 10,000 ends up being 0.75 milliliters. And that's how much we're going to put in our syringe. And we're going to give them 1 bolus dose directly into their IV on that amount. So that's it. You just got to pay attention to the units on all of these. Here's another one that we will do real quick because this one's a little bit different because we're working with units, 75 units per kilogram. So we're doing it by weight. So the infant weighs 6.4 kilograms. And if you have a vial of 1,000 units per milliliter, how many milliliters would you prepare? So the first thing you have to do on this one is you have to figure out how many units you're going to give the patient because it just tells you per kilogram and our patient weighs this. So you want to start with that. We want to go 75 units per kilogram. right? And our patient, I set that equal to, weighs 6.4 kilograms. Okay, so we're solving for X because we don't know what the units are. So we're going to cross multiply and divide. So 75 times 6.4 ends up being, we're going to give them 480 units. Okay, so now we can set that equal to our stock volume. So we need 480 units, and we're going to put that over X milliliters because we don't know how much that is, and set that equal to our stock volume, which is 1,000 milliliter or units over 1 milliliter. So now we're going to cross multiply and divide here. So divide 480 times 1 is 480 divided by 1,000 ends up being, our answer is 0.48 milliliters. And that's our answer right there. Sorry, the math is, the numbers are hard to do it on this mouse, but I think you guys get the idea. So that's a two-step problem, and I wanted you guys to see that. So it's a word problem again, and you just have to slow down and think through them each time and figure out what you're calculating for. So the last thing I want to talk about, and I'm not going to go into too much detail, and you guys, I'm going to post this PowerPoint for you guys to look at, and you guys can watch the video that's on the end of this, but we are going to be doing a project. You guys will have a project to do at the end of this course, the day in the life of a type 1 diabetic. And you guys are going to actually do all the insulin dosing calculations as a diabetic would have to do. So understanding insulin is really important. And insulin is dosed in units based on the amount of glucose that a specific amount of insulin can make available to the cells in the body. There's lots of different delivery systems. You can deliver with an insulin, a syringe and a vial of insulin, where they pull up the insulin from a vial and give it in a syringe that's like this. There's insulin pens, which are the jet injector or insulin pens that look like these two. And then there's insulin pumps, and this is an example of an insulin pump. So they have all these different options. The one thing you need to know, and I'm going to circle this because you guys need to know this, is that the standard concentration of insulin is 100 units per milliliter. That's important to know right there, 100 units per milliliter, always. Sometimes insulin labels can be challenging to read, so it's critical to select the correct insulin product when you're filling a patient's order. A patient with type 1 diabetes, they rely on their insulin injections to maintain their glucose levels. So all T1Ds, which is what I refer to as a type 1 diabetic, must calculate their carbohydrate amounts in grams and then take it with each meal and dose their insulin accordingly. In Module 8 is a lecture videos explaining how to calculate insulin ratios, sliding scales, and correction units for type 1 diabetics, which is part of your final project in this class. So if you want to take a look at that, you can. And then here is a video explaining diabetes, how insulin works, and I highly encourage you to watch this. I am going to go ahead and post it on the lecture component as well. So very important for you to watch. So that's all I have for this unit. That's all the lectures, and good luck to you.